Welcome back, everyone, to the Foundry by Forge College. Look, if you're joining us straight from our previous lesson on monitoring basics and compliance, you already know that alerts without any context are basically just noise. So today, we're transitioning from simply setting up alarms to doing some active detective work. We are right in the thick of the Deploying on Solana track, specifically focusing on monitoring and troubleshooting deployments within our Introduction to Solana Deployment course. Today's explainer is all about identifying common deployment issues. Because, let's be honest, we've all stared in absolute horror at a massive sea of red error logs at 2 a.m., right? By the end of this, you're going to know exactly how to detect and categorize typical deployment failures using logs and a few key performance metrics so you don't have to panic the next time things go sideways.
Okay, here's our game plan for today. We'll start with the triage funnel, talk about why symptoms definitely aren't causes, interrogate some logs and metrics, go over a real-world triage checklist, automate that detective work, and finally wrap it all up with a final debug report. All right, let's jump right in.
Welcome to the triage funnel.
So our main goal today is actually pretty simple. We want to take those terrifying, chaotic midnight alarms and turn them into a cold, calculated debug report. And to do that, we use a visual mantra that you absolutely need to memorize. It's a funnel. We start at the top, super broad, with alerts. Those alerts give us our time. That funnels us down into the metric window, which helps isolate the anomalies. And finally, that narrows down to our exact log extraction. So say it with me. Alerts give the time gives the metrics give the logs. It's a simple flow, but man, it really saves you from just drowning in a sea of data.
Moving on to Section 2. Symptoms are not causes. Look, when a deployment completely fails, it honestly feels like walking into a chaotic crime scene, right? But you've got to remember this one crucial thing. Symptoms are not causes. Think of the symptom as a broken window. It's what you actually observe, like screaming PagerDuty alerts, endless timeouts, or pods just randomly restarting. But the cause? That's the rogue baseball that actually broke the window. It's why it happened. Maybe it's a nasty logic bug, or, one of those famous quick fixes someone casually pushed to production on a Friday afternoon. A symptom just points you in the right direction. It is definitely not the root cause.
So, to actually separate that broken window from the baseball, you've got to ask yourself 3 golden detective questions the absolute second an incident alert goes off. 1. Exactly when did it start? 2. What changed recently? And 3. Which specific component is screaming the loudest right now? Getting answers to these 3 questions right away, it immediately stops that initial panic and focuses your brain on gathering actual useful evidence.
All right, Section 3, interrogating logs and metrics.
Okay, sticking with our crime scene analogy here. Your logs are your eyewitnesses, and your metrics, those are the hard forensic evidence. But to actually use them, you've got to know exactly where to look. We call this the incident window. It's basically the specific few minutes right before and right after a symptom pops up. I mean, if you're looking at logs from an hour ago, you are literally interrogating the wrong witnesses. You've got to filter the time so you can filter out the noise.
Now, once you've dialed in that right time frame, you use what's called a correlation key. These are specific identifiers, things like request IDs, transaction signatures, or slot numbers. Think of a correlation key as the physical thread tying the witness testimony of your program logs directly to the hard evidence of your RPC and validator metrics. For instance, if a program panics, you grab that specific transaction signature from the log, and then you go check if that exact signature aligns with a massive spike in RPC latency.
Which brings us to Section 4, the real-world triage checklist.
To stop yourself from going down a million rabbit holes during those crucial first 10 minutes of an incident, you really need a strict checklist. Let's say your observed symptom is a high RPC error rate. Well, your first metric to check is RPC latency, specifically the P95, and your target log artifact is going to be a server-side error with a signature. What if you're seeing repeated panics? You hunt for CPU spikes or out-of-memory events, and you look for stack traces. Or maybe block production is super slow. You check slot times and look for validator timeout logs. This matrix dictates exactly what evidence you pull first. Absolutely no guessing allowed.
And here's where it gets cool. By combining these things together, you organically build a really strong prioritized hypothesis. Let's say you correlate spiking RPC latency with a bunch of timeout logs. Boom, your primary suspect is probably a network or queue issue. But what if your metrics look completely normal, like CPU is totally fine, latency is perfectly flat, but your program logs are showing all these assert failures?
Well, then you can pretty confidently prioritize a program-level logic bug or maybe just some really bad client inputs. You see how mashing the two together paints the entire picture?
All right, Section 5, automating your detective work.
You know, in our Forge College learning community, we actually see a lot of students manually hunting through logs line by line, which is great for learning, but it is absolutely terrible if you're on a 3 a.m. on-call rotation. The good news? You can totally automate this detective work with a really simple Python script in just 3 steps. Step 1, you parse your logs for high-severity markers like panic or error and extract those signatures. Step 2, load up your time-stamped metric CSV. And step 3, you just correlate them. You have the script find metric samples that fall within a 30-second window of your log events. And just like that, you've completely automated the entire triage funnel. Pretty sweet, right?
Finally, Section 6, the final debug report. This report right here, this is your ultimate objective. It's your final case file. Keep in mind, you are not actually fixing the bug at this stage. You are just compiling a really concise, evidence-backed list of suspects. Your debug report is going to contain your correlated rows, so the timestamp, the signature, the metric, and the log. That way, when you hand this off to an engineer, or even if you're just looking at it yourself the next morning after some coffee, it clearly says, look, here's what broke, here's the hard evidence, and here's exactly where we need to start fixing it.
Before we wrap up, I want to leave you with one final, incredibly practical principle to keep your triage entirely focused. Keep this etched in your brain. Always bind logs to a time window defined by metric anomalies and prioritize hypotheses that explain both. Just remember the funnel, right? Alerts point you to the metric window, and the metric window points you directly to the log extraction.
So the big question, are you ready to turn those symptoms into actual solutions? For our next lab on debugging techniques, I want you to go ahead and assemble a 10-minute incident data set so we can practice some targeted fixes. And that wraps up today's explainer. As always, this was brought to you by Forge College. Be sure to head over to Forge College to dive way deeper into Web3, grab some more resources, and hopefully sleep just a little bit sounder during your next big deployment. Happy debugging, everybody!